An introduction to the law of cosines. In this scenario, we're given two sides and one angle in a triangle. If I was given a situation where my angle matched one of my sides, so like I have side x here and this would have been angle x, I would be going to the law of sines, as you've already learned, the law of sines. But with the law of cosines, I don't really have that scenario here. And so I can kind of draw a little picture of what's going on. I've got this angle that's 32 degrees. I've got a length that is 4. And I've got a length that is 7. Now that length that is 7 would have to be over here, because if I call this big angle X, big angle Z, this would be big angle Y. Angle Y would have to open up to side Y. So this would be 7 here. So it's kind of a side angle side scenario. I'm trying to figure out what this other side would be. I can't use the law of sines because I at least need an angle and its respective side to use law of sines. And so I can't use that for my starting point here. So law of cosines is what we would use. The formula is very much like the Pythagorean theorem with a slight variation. And so I'm going to write it and I'll explain how to do this. It tells me to find side z, which would be little z. Little z squared is equal to little x squared plus little y squared. Now as you look at this, I don't know if this is a right triangle or not. So that would be the Pythagorean theorem where you say leg squared plus leg squared equal the hypotenuse squared. However, looking at this, I don't believe that z would be my hypotenuse. So there's a variation to this. There's a second part, so to speak. You have to say minus 2 times x times y times cosine of that angle. So it's kind of weird here. If you're looking for a side, you will square the other sides of the triangle. You will subtract twice the product of those sides, so minus 2xy, and then take cosine of the angle for the side that you're looking for. Okay, now we'll look at this a couple different ways. We'll try to establish the understanding here. I want to first do this problem. I am looking for z squared. Actually, I'm looking for z. I'm going to start with z squared. As I look for z, if you recall, we talked about the existence of a triangle. That's a theorem or a postulate. The existence of a triangle tells me that this third side has to fall somewhere between the range when I add and subtract these two known sides. So if I subtract these, 7 minus 4, I get 3. If I add them, 4 plus 7 would be 11. I know that this missing side has to have a value somewhere between 3 and 11. Let's just put that on the back burner for a minute. We know that this is going to be somewhere between 3 and 11. I have this newfound formula which is called the law of cosines that states if you're looking for a side, simply square the other two sides of the triangle, subtract the product of each side, times cosine of the angle for the side you're looking for. And so I'm just going to plug this all together now. I don't know the little z, so I'm going to say z squared is equal to x, side x is 4, so 4 squared would be 16, y is 7, there's side little y is 7, so that's squared is 49, minus 2 times 4 times 7 times cosine. Now I have this angle, that's 32 degrees. Looks like a lot of work there, but really my calculator can handle most of this. So I'm going to go to my calculator and I'm going to type exactly what I see. I'm going to say 16 plus 49 minus 2 times 4 times 7 I'm just typing in what I spoke there. 16 plus 49 minus 2 times 4 times 7 cosine 32. And as always, constantly remind you guys, please make sure your calculator is in degree mode. I can see that on my menu. Yours may not have that there. You can always check by hitting the mode button. Make sure that degrees is highlighted. Now I hit enter. Now this is giving me an answer of 17.509 dot 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 dot. It goes on and on and on. And we've talked about keeping these long decimals in your calculator. You don't want decimal error. You don't want rounding error in your calculations. I'm not done yet because I needed an answer that fell between 3 and 11. I've got 17 and change, but that's for z squared. So I'm going to have to square root this number that I have on my calculator. It's pretty easy to do. I can hit second square root. For some of you, you can go up and highlight that number. For others, you may have to go second and then the answer button down here, which just says call up the last answer that I had. Either way will work. And then you hit enter, and I'm getting z is equal to 4.18. I'll round 2 decimal places. And that 4.18 falls in that range from 3 to 11, so I feel very comfortable about that value. Now, if I wanted to solve the rest of the triangle, once I have this angle, which was given to me, and this side, that sets up the law of sines. It tells me that I can go to law of sines. I don't have to use this elongated formula. And so then I could do, say I'm looking for the angle x there, I can do sine of x over 4 is equal to the sine of 32 over 4.18. In fact, I'm actually going to do that here to show you how to do it. We're going to go back to what we've already learned, law of sines. The law of cosines and the law of sines are really one and the same. They're related to one another. You can't do one without the other. So as I said, I'm going to set this up and I'm going to look for this sine x. I'm looking for x. So I'm going to say sine of x over the side opposite x is 4 is equal to, now I'll go with the information I have, the sine of 32 over this newfound side of 4.18 and change. Notice how I said 4.18 and change. I'm still going to use that calculator with all the decimal in there so I don't have rounding error. And so to solve this, I could simply take that 4 up, go sine of x is equal to 4 times sine of 32 divided by 4.18 and change. So in my calculator, I'll go 4 times sine 32, and I'll divide by that 4 and change number that's on my calculator. So I just go up there, I'm going to highlight it this time. That brought it down here. I hit enter. That tells me that sine of x is equal to 0.5065 and change. But I don't want sine of x, I want x. I want to know the value of that angle. So to undo this, I can do my arc sine or inverse sine. Arc sine here, arc sine there. And this takes me to an x, and I'll simply put that in my calculator. I'll say second sine, and I take that number, and that tells me my angle there is 30 point, I'm going to go 2 decimal places, 0.44 degrees. X is equal to 30.44 degrees. And we'll come back up to this triangle. If I know this to be, angle x is 30.44 degrees, well, I know that there's 180 degrees in a triangle, so I can add these up, subtract from 180, and I can find that summit angle. which I might as well do. We got this much done. We might as well do all of it, huh? So I'll go 180 minus 32 minus 30.44. It tells me that summit angle is 117.56 degrees. So this is 117.56 degrees. And that's how you would use that law of cosines.